Two-wire ology talks. Two-wire splices. To best describe a two-wire installation method, there must be a why. This two-wire talk is about successfully sustainable two-wire splices. Successfully is the key word. I am sharing one method, and I'm sure there are several others. The what is simply the hardware, from the irrigation controller to the two-wire cables to the decoders and their solenoids. The how is the electrical continuity and communication between the irrigation controller and its decoders over just two wires. Also keep in mind that through these two wires, you must create communication with each individual field decoder and possibly even sensors like rain and flow sensors. Because communication is just as important as the voltage load, the installation method is almost always the why two-wire systems work as expected or fail. Consider the electrical load of all irrigation valve solenoids connected to one irrigation controller via just two wires. Emphasizing the why, let's take a moment and review some manufacturers' manuals. These DBRY6 splice kits and waterproof silicone-filled wire nuts are filled with dielectric grease. Even though it has electric in the name, dielectric grease is an insulator and does not conduct electricity. The intention of dielectric grease in landscape field splice kits may be to help keep splices quote-unquote dry from moisture, yet even this grease dries out over time, creating small cavities where water can find its way to the actual wire splices. This is why I try to keep all field splices vertical, with the dry wire nuts in the DBRYs on top. This is also why I never use any silicone-filled wire nuts. Two-wire field splices must be dry to allow the proper voltage and frequency communication to travel through two wires to each field decoder. The non-conductive dielectric grease can also fill the tiny voids between the wires and in any splice, which could lower the continuity between those wires. Consider how many splices the voltage and frequency communication must go through to reach the furthest decoder on a two-wire irrigation system. In addition, dielectric grease is a fluid that I have seen settle within or weep out of DBRY6 splice kits. Over the years, I have seen many oxidized wires on decoders, solenoids, flow sensors, and this is also a red flag to hardware failing in the field. Before I share my exact method, please note that this method is my preference, which is subjective to others' installation methods of two-wire decoders. I strongly encourage all contractors to have the correct tools ready to work on any two-wire decoder system. Please see the two-wire bucket toolset link in the description of this video. When installing irrigation valves in a landscape after running the main line, I installed a T with a ball valve where every valve assembly would go. I ran a two-wire cable along the landscape water main line, leaving a loop over every ball valve where the future valve assemblies would be installed. I would build valve assemblies on the, say, tailgate of my truck, including all of their wire splices.
So I will start a timer to show my average time to fully splice decoders to irrigation valves. I always prepare the two-wire cables to their exact lengths to be installed for every valve. This method helped me install each decoder efficiently and allowed the two-wire system to work as expected for a long time. Here I have a 3-valve assembly with a single station decoder for the first valve and a 2-station decoder for the following two valves. I always start by running the first jumper two-wire cable to a length of around 10 inches above the first irrigation valve solenoid. Then I will cut the following jumper two-wire cables to make the splices more efficient with my installation time. Notice that I try to keep the jumper cables around 10 inches above the solenoids. This allows for a good length of the two wires to be fully seated correctly in the DBRY6 caps. Also, once I cut the second valve's jumper wire cable, I can quickly cut the following jumper wire cables to their specific length. Once the two-wire cables are all cut, I use my UF cable stripper tool to expose the two wires. This tool also helps me to quickly expose the two wires in my preferred choice of two-wire cable, P7072D. I also like to keep a small trash bucket next to my workspace to expedite the cleanup time after the splices are done. Remember that installing two-wire decoders is like science and art combined. Holding the two-wire cable, I use the distance from my thumb to pinky, right around 10 inches, to remain consistent with the amount of outer polyethylene I will cut to expose the two inner wires. Through my experience, using the UF cable stripper tool on the P7072D 2R cable has been the most productive method to properly expose the two wires. After the 2R cables are properly prepared and ready to splice, I use zip ties to begin placing the 2-wire along the pipes of the valve assembly. This keeps the wiring in its place and allows for a quick and easy installation of the complete assembly after the decoders are installed. I like installing the first jumper cable next to the first valve's solenoid. Then I can quickly install the following jumper cables with the zip ties to the remaining valves. When installing a multi-station decoder, I install that decoder nearest the first valve it will operate, using jumper cables for the remaining irrigation valve solenoids. I strongly recommend never installing jumper cables between the decoder and the solenoid longer than 20 feet. Notice I mentioned jumper cables, not jumper wires. Only installing 2-wire jumper cables will allow for future additions of irrigation valves and decoders to landscapes that may potentially expand. Please ensure to never cross polarity within your 2-wire cables, keeping looped systems from ever having any hard electrical shorts. Again, I encourage using pliers to make the wire splice twists and only use dry wire nuts to keep those splices dry. A simple set of pliers is included in this 2-wire bucket toolset. The DBRY6 splice is designed to keep those splices dry. Please make sure to identify the 2 wires of the solenoid wires on every decoder. Every decoder isolates its voltage loads over a pair of wires to each solenoid. Some decoders have a shared common wire, while others do not. Please ensure you know before starting these splices. When all of the 2-wire wires are ready to splice, I use my wire strippers to expose around 1 inch on every wire. Having the trash bucket nearby helps throw away all the extra polyethylene. I have heard of certain individuals claiming that the wire nut should make the wire splice. However, I have seen splices made with the wire nut where the splice was over tightened with cracked wires inside that wire nut. Using simple pliers can help you see and feel the correct amount of torque needed to twist the wires together without over tightening and accidentally cracking any wire in your splice. I prefer to see my wire splices, and I always prefer to use simple pliers to twist the wires together. Remember that the only true intention of the dry wire nut is to keep those splices dry. I like to install the dry wire nuts just finger tight. After the wire nuts are installed, I will move on to the DBRY6 caps. 2 critical details here are my push tool and a bag of cotton balls. Every time I install a DBRY6 cap, I like to place a cotton ball near my pinky while holding the new DBRY6 cap. Then I will grab the push tool with my other hand and let the dry wire nut simply touch the dielectric grease within that cap. With the dry wire nut only touching the grease, I will use this push tool to fully insert the dry wire nut in the DBRY6 cap, keeping those wires dry. After the dry wire nut is fully seated, I will carefully remove the push tool along one side of that grease-filled cap, then use the cotton ball to clean that push tool. After my push tool is cleaned, I will set it aside and move the wires and insert that same cotton ball in the base of that DBRY6 cap. Then I will clip the cap shut and repeat for all other wire splices. Also notice that I only use the push tool on the more malleable wires from the solenoids and the decoders. The 2R cables have solid 14 or 12 gauge wires that are sturdy enough not to bend when inserting these splices in the DBRY6 caps. The last step to splice a decoder to its irrigation valve is to zip tie the wires so that the DBRY6 caps are vertical with the dry wire nuts on top. This method basically guarantees that even if this valve box fills up with water, the wire splices will always stay dry. I strongly suggest finishing all the splices with the push tool and cotton balls, making sure that all splices stay dry and vertical. I always have a bundle of zip ties in my 2R bucket to tie the splices vertically nearest their solenoids. In the past, I have seen dielectric grease weep out of these caps in hotter climates, which is why I use cotton balls to help quote-unquote slow down that dielectric grease. If these splices were to be quote-unquote upside down, my concern would be for the air within the once dry wire nut to rise and allow the non-conductive dielectric grease to settle within that once dry wire splice, which could make a good splice potentially a bad one. With these splices all zip tied vertically, with the dry wire nuts towards the top. The cotton balls help to create a seal to keep the dialed grease within that splice cap. Here we see that my average time to install a decoder per irrigation valve is around 10 minutes. When I was done building and wiring a valve assembly, I would glue that valve assembly in its place, finish the last splices to the jumper cable above that ball valve, and move on to the next valve set.